Let's take a look at simplifying an algebraic expression. Algebraic expression is a fancy term for you have variables in it. So it's not much more exciting than that for our definition. Let's take a look at our first problem. There it goes. It says evaluate each expression using given values of the variables. We got negative 3p squared minus 4p plus 3 for p is equal to negative 2. The instructions evaluate each expression. Excuse me. So this is steps for evaluating an expression. And again, this is an algebraic expression has variables in it. Our first step. Replace all the variables with parentheses, with sets of parentheses. Now everything else remains exactly as is. The negative 3 remains there, the squared remains there, the minus 4 remains there, the plus 3 at the end remains there. Only thing we did is we went through and everywhere we had a variable we put in a set of parentheses. Now step 2. Plug in the appropriate number not that I can spell. I write so sloppy you can't see that. I misspelled it. Plug in the appropriate number in the parentheses. You know, I used to be really good at spelling. Let me go back there and try that again. Okay, so this is doing real sloppy so you can't tell I screwed it up. Okay. Oops. Appropriate number. Okay. Plug in an appropriate number in the parentheses. I think in 6th grade I was like a spelling bee champion or something like that. When I say plug in an appropriate number in the parentheses, well, this one we just have one, the p. But in other problems we'll have maybe 2 different variables or 3. And we're going to plug this negative 2 in everywhere we had a p. Well, everywhere we had a p is the parentheses right here. Like I say, it'll be a little bit different for the next one. And then step 3 is simplify. Simplify is kind of a vague term. Means get rid of parentheses, combine together numbers, get a single fraction if you can. But we're going to use order operations that we saw in the previous section. Well, first step. Well, please excuse my dear Aunt Sally. First step, you do what's inside parentheses. Well, there's nothing inside of parentheses. Second thing we do is exponents. Please excuse. So excuse part. So we're going to do this negative 2 squared. Remember, the exponent only affects what's to the immediate left unless there's parentheses, and it affects everything. So this will be negative 2 squared, which gives us 4. Please excuse my dear. So I do multiplication next, or division. Negative 3 times 4 is negative 12, minus 4 times negative 2 plus 3, which gives us negative 4 times negative 2, which gives us a positive 8 plus 3. Now the Aunt Sally part, addition, subtraction. So we've got negative 12 plus 8 gives us negative 4 plus 3 gives us negative 1. And that's our answer. Let's take a look at another problem of those. This one has 3 different variables. Now we're going to use the same steps. So we've got 5y minus z plus x over x minus y, and for x equals 2, y equals negative 3, and z is equal to negative 1. And instructions still are to evaluate the each expression. Again, for our first steps, to go through and everywhere we have a variable, put in parentheses. Everything else remains exactly as is. We're just replacing the letters with sets of parentheses. Now, the second step was to plug in the appropriate number in parentheses. And again, what that means is here x is equal to 2, so everywhere we had an x, we'll put in a 2. So put a 2 here and put a 2 here. Now y is equal to negative 3, so everywhere we had a y, we'll put in a negative 3. And z is negative 1, so everywhere we had a negative 1, we'll put in, or everywhere we had a z, we'll put in negative 1. Okay, so we've got 5 times negative 3. Remember our shortcuts. Negative parentheses negative becomes a positive. And that last parentheses isn't doing anything, so you can drop it. Down here, first set of parentheses isn't doing anything. Minus parentheses minus becomes a plus. You apply those anywhere you can before you do anything else. Makes your problem simpler. Up on top, I'll do my order of operations. 5 times negative 3 is negative 15. Plus 1 plus 2. Down below, 2 plus 3 is 5. Up on top, negative 15 plus 1 is negative 14. Plus 2 over 5. Which gives us negative 12 over 5. So that would be your answer. Assuming I didn't make a basic math error somewhere. 16, 18, negative 15, negative 14, negative 12 over 5. Yep, that's right. And I think I got one more of those. So let's look at this one. Do it up over here. Got a squared minus 5b squared. And a is negative 2 and b is negative 3. Okay. First step, go through and replace our variables with parentheses. Everything else remains as is. And step 2, plug in your appropriate number into the parentheses. Here we say a is negative 2, so we'll put negative 2 in for a. B is negative 3, so put negative 3 in for B. And now we use our order of operations, step 3, to simplify this. Please excuse my dear Aunt Sally, there's nothing to do inside the parentheses. Excuse, exponents. Well, I'm going to do the negative 2 squared first. That gives us 4, and everything else carries down. So I have one more exponent, the negative 3 squared. So that's going to give us a positive 9. My dear, multiplication division. 5 times 9 is 45. And Aunt Sally, addition subtraction. 4 minus 45 gives us negative 41. Now I'm going to start a new page for this next problem. And have my tablet blow up, so I'm going to bring up a new copy of it. There we go. This is best shown by an example, so that's why I want to do it using this particular problem. We have 2 times 3x squared minus 7x plus 4. It says use the distributive property to remove the parentheses. Well, a 2 out in front of this indicates multiplication. Now inside we have 3 different items. When I say 3 different items, they're separated by pluses and minuses. So we're going to take this 2 and multiply it times the 3x squared. We'll multiply it times the negative 7x and times the 4. Now we're going to be talking about terms here shortly. Oftentimes these are terms, but they don't have to be. They can be anything, just as long as they're separated by pluses and minuses. So a lot of people get thinking distributive property has to apply to terms, and it doesn't. You can have items in here that aren't terms. They could be square roots, which we haven't talked about yet. They could be absolute values. Well, we're gonna follow the lines here. So we're gonna take 2 times 3x squared. We're gonna take 2 times negative 7x, and we're gonna take 2 times 4. Now, when you're multiplying, and we're going to talk more about this later, but when you're multiplying a number times a number and a variable, variable's it's a value we don't know. We don't know what x is. What you do is you multiply the 2 times 3, gives us 6, and then the x squared remains. In the previous problems, we knew what the variable was. We would plug the value in for it. Well, here we don't. 2 times negative 7 is negative 14, and you put the x beside it. And 2 times 4 gives us 8. Now, this is our answer using a distributive property. Let's take a look at one more in distributive property, and then we'll talk about some. Well, actually, there's 2 more. And here we got 4a minus b. Again, this negative 3 next to the parentheses indicates multiplication. So we'll take negative 3 times the 4a and times the negative b. So we've got negative 3 times 4a and negative 3 times a negative b. Well, that gives us negative 3 times 4 is negative 12, and the a remains. Again, the a is a variable we don't know, and when you're multiplying, you just put it right next to that. Here's a negative times a negative, which gives us a positive, and then 3 times b is 3b. Now, you're seeing here, I'm putting a number next to a variable. That indicates multiplication. So this says 3 times b. And that's our answer. Okay, so we got 4x minus 7y, and then times 5. Okay, so we have a number here right beside parentheses that indicates multiplication, whether it's out in front or behind. So we're going to take this 5, and then we'll put times the 4x and times the negative 7y. Whatever is separated by pluses and minuses. So we're going to take 5 times 4x and 5 times negative 7y. Well, 5 times 4 is 20, so we've got 20x. 5 times negative 7 is negative 35y. Okay, so keep that in mind. That's a distributive property. We're going to be talking about terms here next, and variables and what all that means. But do not think it has anything to do with that. Distributive property can be anything, just as long as you got something out in front. That's pretty vague, isn't it? Something. Because it doesn't have to be a number, like these indicate. But you have something out in front next to parentheses, you have to take it and multiply times everything inside separated by pluses and minuses. Some books actually refer to that as a distributive property over addition, but you could have subtraction too. So, okay. We've already been referring to variables. This is variable is a single letter. And again, it represents a number we don't know. Now you can have something called a term. This is a number. This is a variable. And I'll put an S on here to indicate you can have more than one variable. Or a number times a variable. And I'll put an S on there to indicate you can have more than one. Examples of terms. 7 would be a term. 5x, a number times a variable, number times a variable. Remember, a number next to an x indicates multiplication. This right here would be a term. And you're sitting there, well, it doesn't say anything about exponents, but I say a variable and I have an S on there. Well, remember what x squared means. That means x times x. Variables, we have 2 x's. That's fine. You could have this right here. I think what this represents, x to the third is x times x times x. Y squared is y times y. Well, that's just variables, isn't it? So they're all set. And when I say variables up here, or number times a variable, everything's multiplication. You can't have any addition. Addition is what separates them. Let me put a note on that. Pluses or minuses separate terms. That's how you can tell when you come across a new term. Excuse me. Now, we're going to be dealing with something called like terms. This is when you have the same variables to the same power. For example, we have 5x and we have 7x. These are both x to the first power. Now the number out in front can be different, but these are both the same variable to the same power. They're both x to the first. If you have an exponent, you don't have a number here, it's by default 1. These are like terms. They're both x to the third power. These are like terms. They both x the first, y squared. So x, y squared. Well, we're going to be combining together like terms, and they're all kind of based upon. I'll show it with an example, but first I'll do a simple example. Okay, now I got 2 smiley faces plus 3 smiley faces. Okay, you have to kind of envision this. Got a table up here. I got 2 smiley faces sitting there. Somebody comes up here and they drop 3 more smiley faces. How many smiley faces we have? Well, we have 5. So this would be 5 smiley faces. Now we're going to be doing the same thing, but we're going to be doing with x's or other items. So if this is alike, no matter what it is, and that's a lot of times when we first start out with this, we think they have to be like terms, but there should be like a property that says like items. If these are like items, they look the same except for the numbers out in front of them, then you can add or subtract the numbers. So let's look at some problems dealing with that. We got 7m minus 2m plus 3m. Now it kind of gives us a hint. Let me grab a drink before we start these. It says simplify each expression by using the distributive property, remove parentheses, and combine together like terms. Well, in this particular problem, we don't have any any parentheses, sorry, but we do have like terms. Let's look at these first 2 here. 7m minus 2m. Again, we add or subtract the numbers that are out in front, so 7 minus 2 gives us 5m, and I'll bring down to 3m. Now these are still like terms. They're both m to the first power. So I add these together. 5m plus 3m gives us 8m. And that's our answer. Again, it's the same idea as the smiley faces up on the table, on the way to think of it. Now here we have this. Now, if I went back to my Dear Aunt Sally says do what's inside the parentheses. If I look at what's inside the parentheses, these are none of these are alike. There's no like terms. This is x squared. This is x to the first power. This is just a number. So then, please excuse. There's an exponent, but there's nothing to do there. My dear, multiplication. Well, here we just have a negative in front of the parentheses. And up above with the distributive property, we had numbers. If there were to put a number here, it'd be the invisible 1. So in this problem, we're going to take negative 1 times negative x squared times the negative 5x and times 6. Well, negative 1 times negative x squared gives us a positive x squared. Negative 1 times negative 5x gives us positive 5x. And negative 1 times 6 gives us negative 6. There's no like terms combined together here, so that's our answer. Basically, a negative out in front of your parentheses flips the sign of everything on the inside. So negative x squared becomes positive, negative 5x becomes positive, the positive 6 becomes negative. Let's look at this one. Five times x minus 3 minus 4x. Okay. Now, if the instructions weren't telling us exactly what to do, I'd hit this problem and I'd think, okay, order of operations. Please excuse my dear Aunt Sally. Please do what's inside the parentheses. Well, there's nothing inside the parentheses. Please excuse exponents. There's no exponents. My dear, multiplication and division. Well, I have a 5 right in front of the parentheses. That indicates multiplication. So we're going to take this 5, multiply it times the x, and times the negative 3. 5 times x is 5x. 5 times negative 3 is negative 15, minus 4x. Now there's no more multiplication division, so Aunt Sally, addition, subtraction. Let me rearrange this so like terms are together. Like terms, the same variable, the same power. So I put the this is 5x, this is negative 4x. I put those together. Now when I move things, the sign that's in front of them has to go with it. So this negative 4x, the negative went with it, and this negative 15, the negative went with it. Now addition, subtraction. Well, that includes combining like terms. So here we have 5x minus 4x. That's going to give us a positive 1x or just x. If you have a 1 here, typically you just drop it off, and this would be your answer. Can't combine the x and the 15 because they're not like terms. Let's look at another problem. Got negative 2 times 4x minus 3 minus 5 times 6x plus 1. Again, if the instructions didn't tell us what to do, I'd hit this problem and do my dear Aunt Sally procedure. Please excuse my dear Aunt Sally. Do what's inside the parentheses. Nothing to do inside the parentheses. Excuse. Exponents? No. My dear. Multiplication, division. Well, I got a negative 2 in front of the parentheses, so I'll take the negative 2, multiply it times 4x, and times the negative 3, and take the negative 5, and multiply it times 6x, and times the 1. Now, negative 2 times 4x, we've already talked about this. If you got numbers and a variable, you just multiply numbers together and leave the variable as is. Negative 2 times 4 gives us negative 8x. Negative 2 times negative 3 gives us a positive 6. Negative 5 times 6x gives us negative 30x. And negative 5 times positive 1 gives us negative 5. Now you don't have to rearrange the terms, but if it helps, go ahead and do that. Put the like terms together. So I got negative 8x and negative 30x. And I got 6 and negative 5. Well, Aunt Sally. Addition, subtraction. Again, combine together like terms. Negative 8x, negative 30x is negative 38x. 6 minus 5 gives us 1. So that's our answer. Here we got 2/9 x plus 1/12 x. Well, here, they're like terms. In order to combine these together, we want to get a common denominator. To find our least common denominator, remember we do the prime factorization of each denominator. 9 is 3 times 3, and 12 is 2 times 2 times 3. Now we start with each prime, start with a 2, and we're looking for the greatest number of 2's on each single line. There's none here, there's 2 here, so we'll use 2. Then we'll go to the 3. We're looking for the greatest number of 3's on each single line. There's 2 here, there's 1 here, so I'd use 2. So that's 4 times 9, which gives us 36. Well, I want to rewrite each fraction with that new denominator. On my first fraction, I multiplied the bottom part by 4 to get my new denominator, so I have to multiply the top part by 4. On a second fraction, I multiplied the bottom part by 3, so I have to multiply the top part by 3. So that gives us 8 over 36x plus 3 over 36x. Well, they have the common denominator now, so I'll add them together. 8 plus 3 is 11, 36x. And that's our answer. Let's look at one more. Got 1/3 and 6x plus 2 minus 1/4 8x plus 1. Now again, the instructions wouldn't have to tell us to get rid of parentheses because dear Aunt Sally tells us to. So we're going to take 1/3 times 6x, 1/3 times 2. and negative 1/4 times 8x, and negative 1/4 times 1. Let me write that out. We got 1/3 times 6x plus 1/3 times 2 minus 1/4 times 8x minus 1/4 times 1. A lot of people have trouble with fractions, so let me put this in a little bit more user-friendly form. User-friendly. I'll put this 6 over 1. If you're going to multiply fractions, they both should be fractions. I'll put this as 2 over 1. I'll put this as 8 over 1. Now notice the variable I'm not putting up there because it really doesn't matter because we're just going to multiply numbers together. And then 1 over 1. Okay, so here the 3 and 6 are going to reduce. That becomes 1. This becomes 2. So this gives us 1 times 2 is 2 over 1 x plus 1 times 2 over 3 times 1, so 2/3, minus the 8 and 4 reduce. They both divisible by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So we got 1 times 2, which is 2 over 1 x, minus, and 1 times 1 is 1. 4 times 1 is 4. You get that. Which gives us 2x plus 2/3 minus 2x minus 1/4. Well, let's rearrange things so like terms are together. So we got 2x minus 2x plus 2/3 minus 1/4. Well, 2x minus 2x drops away. And we got 2/3 minus 1/4. Well, let's get a common denominator. Our least common denominator, if I look at each one, 3 is already prime, so we're fine with that. And 4 is 2 times 2. Now we'll start with our first prime, 2. We're looking for the greatest number of 2's on any single line. There's none here, there's 2 here, so I'll have 2. Then we'll go to the next prime, 3. I'm looking for the greatest number of 3's on any single line. There's 1 here, none here, so it'll be 1. And that'll give us 12. So I'll rewrite each fraction with a new denominator. Now here I multiplied the bottom part by 4, so I have to multiply the top part by 4. In our second fraction, I multiplied the bottom part by 3, so I have to multiply the top part by 3. So that gives us 8/12 minus 3/12. They have the same denominator, so 8 minus 3 gives us 5. And our answer is 5/12. And that's the end of that presentation section.